Hello everyone. Today's topic is Cannizaro's reaction. It's very important for board as well as entrance. Whenever you study Cannizaro reaction at home, please compare with aldol condensation. So try to understand. During aldol condensation, both aldehydes and ketones undergo condensation reaction provided that they should have alpha hydrogen atom. During Cannizaro reaction, only aldehydes, no ketone, undergo disproportionation reaction. In aldol condensation, the reaction occurs in presence of dilute alkali. During Cannizaro reaction, the reaction occurs in presence of concentrated alkali. In aldol condensation, whether you take aldehyde or ketone, take two molecules. In Cannizaro also use two molecules. Now understand Cannizaro's reaction. During Cannizaro reactions, the molecules of same compound, I repeat, the molecules of same compound simultaneously undergo oxidation and reduction. One molecule undergoes reduction to primary alcohol, that is CH2OH group. Another molecule of aldehyde undergoes oxidation to carboxylic acid, that is COOH. As the reaction takes place in alkaline medium, and remember it, acid and alkali never coexist. That's why finally we get salt. Cannizaro reaction is not a redox reaction because during redox reaction, two different reactants are used. For example, imagine copper oxide, that is CuO. Don't write, only understand. When copper oxide reacts with hydrogen, you get copper and water. Hydrogen undergoes oxidation to give water. Copper oxide undergoes reduction to give copper. This is redox. This is an example of redox reaction because two different molecules, one undergo oxidation, another undergo reduction. But Cannizaro reaction is not a redox because the molecules of same compound, not different, simultaneously undergo oxidation and reduction. That's why Cannizaro reaction is an example of disproportionation reaction. So during Cannizaro reaction, aldehydes having no alpha hydrogens are used. Aldehydes having no alpha hydrogens are used. Can you tell me which of the following aldehydes undergo Cannizaro reaction? Okay, remember it, aldehydes having no alpha hydrogen atoms. So tell me which of the aldehyde undergo Cannizaro reaction. Remember it. Those aldehydes undergo Cannizaro reaction which have no alpha hydrogen atoms. This is formaldehyde. It has no alpha hydrogen atom. Once again, listen, I have already discussed about the alpha hydrogen atoms. Consider the functional group carbon. Here it is aldehyde. The adjacent carbon, if any, called alpha carbon. It has no adjacent carbon, so no question of alpha hydrogen. So formaldehyde has no alpha hydrogen. So formaldehyde undergoes Cannizaro reaction. It's formaldehyde. Benzene having aldehyde, benzaldehyde. It has also no alpha hydrogen atom. It also undergoes. Here it is acetaldehyde. Acetaldehyde has 3 alpha hydrogen atoms. So it does not undergo Cannizaro reaction. This compound, tell me whether this compound undergoes Cannizaro reaction or not. No. This compound is exceptional. Though it has alpha hydrogen atom, still it undergoes Cannizaro reaction. The explanation I will discuss after some times. So let's start Cannizaro reaction, okay? So formaldehyde, benzaldehyde, this compound, they all undergo Cannizaro reaction. This is acetaldehyde, does not. During Cannizaro reaction, one molecule undergoes reduction. So aldehyde group reduces to primary alcohol. Another molecule of aldehyde oxidizes to salt of carboxylic acid. Salt of carboxylic acid. This is a salt of acid. That's why Cannizaro reaction is an example of disproportionation reaction, okay? How to remember the Cannizaro reaction? Listen the technique. So this is the technique to know the Cannizaro reaction. One molecule of aldehyde reduces to primary alcohol. Another molecule of aldehyde oxidizes to salt of carboxylic acid. Salt of carboxylic acid. Now example. How to write it? Listen the technique. Remember, during Cannizaro reaction, 2 molecules are used. Change 1 molecule of aldehyde into primary alcohol. The hydrogen remains as it is. So, compounds containing only one OH group called methanol or methyl alcohol. change another aldehyde group into salt of carboxylic acid. One carbon having carboxylic acid is called formic acid. So it is sodium salt of formic acid, that is sodium formate. So one aldehyde undergoes reduction to primary alcohol. Another molecule of aldehyde oxidation to salt of carboxylic acid. That's why Cannizaro reaction is the best known example of disproportionation reaction. Example second. With benzaldehyde. Two molecules of benzaldehyde react in presence of concentrated sodium hydroxide. You can use potassium hydroxide also. This is benzene having CH2. If benzene contains CH2 on the head, that's called benzyl. Compound containing OH group called alcohol. So it is benzyl alcohol. This is benzene having carboxyl acid group on the head called benzoic acid. This is sodium salt of benzoic acid. That's why it is called sodium benzoate. So I think you understand the Cannizaro reaction. Remember it, during Cannizaro reaction, two molecules of aldehydes are used having no alpha hydrogen atoms, such as formaldehyde, benzaldehyde. One molecule undergoes reduction to primary alcohol. Another molecules undergo oxidation to salt of carboxylic acid. Now, this is another example of Cannizaro reaction occurs between aromatic aldehyde, that is benzaldehyde, which has no alpha hydrogen atom, and aliphatic aldehyde, that is formaldehyde, which has also no alpha hydrogen atom. So let's start. One molecule of benzaldehyde, one molecule of formaldehyde, no one has alpha hydrogen atom, react in presence of concentrated potassium hydroxide. You can use sodium hydroxide too. You know that during Cannizaro reaction, one aldehyde group undergoes reduction, another aldehyde group undergoes oxidation. Now tell me, what are the products? It may undergo oxidation or reduction, it may undergo oxidation or reduction. But there is one technique to remember it. Remember, during Cannizaro reaction, if one molecule is formaldehyde, it always undergoes oxidation to carboxyl acid salt. Once again I repeat, during Cannizaro reaction, if one molecule is formaldehyde, it always undergoes oxidation to salt of carboxylic acid. This is the main thing. Remember it. This type of Cannizaro reaction is called crossed Cannizaro reaction. So during Cannizaro reaction, if one molecule of aromatic aldehyde, that is benzaldehyde, and one molecule of aliphatic aldehyde, that is formaldehyde, undergoes reaction, then remember it, formaldehyde always oxidizes to salt of carboxylic acid, and this type of reaction is called crossed Cannizaro reaction. So what are the products formed here? Obviously, this aldehyde undergoes reduction. As it is formaldehyde, it undergoes oxidation. As you take potassium hydroxide as the alkali, so use K here. So you get potassium formate. This is the very important conception for entrance also, okay? This is the very important conception for entrance also. Now, let's start another type of Cannizaro reaction, that is intramolecular Cannizaro reaction. Understand it? If a compound contains two aldehyde groups having no alpha hydrogen atoms, then intramolecular Cannizaro reaction takes place. One molecule of aldehyde reduces to primary alcoholic group, that is CH2OH group, and another molecule of aldehyde oxidizes to salt of carboxylic acid. So let's understand intramolecular Cannizaro reaction. Intramolecular Cannizaro reactions. If a compound contains two aldehyde groups, then one aldehyde group undergoes oxidation, another undergoes reduction. So try to understand it. This is glyoxal. When it reacts with concentrated sodium hydroxide or 50% sodium hydroxide, same thing. One molecule undergoes reduction. Another molecule undergoes oxidation to carboxylic acid, which changes into salt. Now, this compound, if treated with dilute HCl, then you get carboxylic acid. So you get glycolic acid. This is an example of intramolecular Cannizaro reaction. One molecule changes to primary alcohol CH2OH. Another molecule will change into salt of carboxylic acid. If this compound treated with dilute hydrochloric acid, the salt will change into carboxylic acid group, so you get glycolic acid. This is an example of intramolecular Cannizaro reaction. Okay. Now let's start another type of reaction, that is Claisen-Schmidt condensation. Claisen-Schmidt condensation. This is the condensation reaction between one molecules of benzaldehyde having no alpha hydrogen atom, one molecule of acetaldehyde having alpha hydrogen atoms. The reaction takes place in presence of dilute sodium hydroxide. Dilute. Can you tell me, this is a type of Cannizaro reaction or aldol condensation? See, this is a type of aldol condensation type of reaction because the reaction occurs in presence of dilute alkali. Because one of the compound contains alpha hydrogen atom. I repeat, one of the compound contains alpha hydrogen atoms. So aldol condensation takes place. Now follow the technique. I have already delivered a lecture on aldol condensation. During aldol condensation, draw the first molecule, first compound as normal structure. Let's check. Benzaldehyde, whenever you write the second molecule, write one alpha hydrogen atom separately. There are 3 alpha hydrogen atoms in acetaldehyde. Write only one alpha hydrogen separately. What is the technique? As oxygen has more electronegative than carbon, so oxygen attracts one pi bond. So oxygen becomes negative charge and carbon becomes positive charge. This hydrogen gets attached to the oxygen atom and the carbon is attached to this. So you get the product double bond changes to single bond. If this compound is heated, mention only if the question is asked what happens when the product is heated, otherwise no. One molecule of water is eliminated. Hydrogen from here, OH from here, so the bond shifts here. This type of product is called This is alpha carbon, this is beta carbon, and alpha and beta carbon contains double bond, that is unsaturated. So alpha beta unsaturated aldehydes. This is benzene ring, so the compound has general name alpha beta unsaturated aromatic aldehyde. Is very important for entrance. This is a type, this is not the name of the product, this is a general type. And its name is cinnamaldehyde. Cinnamaldehyde. The name of the compound is cinnamaldehyde. It's a type. Understand? And the next reaction, last reaction of this video. This is very important. Listen the reaction. Very important for entrance, not for board. But remember, a beaker is taken here. A beaker is taken here. Add acetaldehyde and formaldehyde. Add some amount of acetaldehyde and some amount of formaldehyde. Use at first dilute sodium hydroxide. Reaction proceeds. After some time, add a little bit concentrated sodium hydroxide. What will happen? Remember it, during this reaction, this is a very important reaction for entrance. Either it is neet or jeemains. During this reaction, the product which is formed has a great significance in pharmaceutical industry because this compound is used to prepare a most valuable medicine for heart attack. Okay, so let's try to understand. Very important. Okay, once again, a beaker is taken here. In a beaker, certain amount of acetaldehyde and certain amount of formaldehyde are taken. At first, add a little bit dilute sodium hydroxide. As the reaction proceeds, just after some time, add a little bit concentrated sodium hydroxide. So let's check the reaction. The reaction occurs with one molecule of some amount of acetaldehyde some amount of formaldehyde. At first stage, use dilute sodium hydroxide and then concentrated sodium hydroxide. What happens when? As the compound contains 3 alpha hydrogen atoms, as the reaction in first step takes place in presence of dilute sodium hydroxide, so in the first step, aldol condensation takes place. I have already told you, whenever you want to write aldol condensation, at first write the other molecule as normal structure, and for second molecule write one alpha hydrogen atom separately. So you get the product. So see, one alpha hydrogen atom of acetaldehyde is replaced by CH2OH group. This is the first step. As acetaldehyde contains 3 alpha hydrogen atoms, so continuously similar type of steps proceed unless and until all the alpha hydrogen atoms of aldehydes are replaced by CH2OH group. Second molecule of formaldehyde. Dilute sodium hydroxide, you have already added, no need to add extra. Another alpha hydrogen atom is replaced by CH2OH group. So can we write it? Listen. Again, this compound contains another alpha hydrogen atom. So this compound again reacts with another molecule of formaldehyde. So this alpha hydrogen atom is replaced by CH2OH group. So this is aldol, aldol, aldol. These three are the example of aldol condensation. This step is also an example of aldol condensation. This step is also an example of aldol condensation. So 3 aldol condensation steps. 3 molecules of formaldehyde are used. Now you add here concentrated sodium hydroxide. This compound has no alpha hydrogen atoms. This compound has no alpha hydrogen atom. So in this step, as you use concentrated sodium hydroxide, Cannizaro reaction takes place. So this compound here Cannizaro reaction occurs. And you get 2 different types of product. One primary alcoholic group, another carboxylic acid. But primary alcoholic group is the major product. So write only primary alcoholic group. This compound is called pentahydroerythritol or shortly hydroerythritol. This is used to prevent heart attack. So this chemical is used as a medicine to prevent heart attack. So see, the reaction occurs between acetaldehyde, formaldehyde. In first step you have used dilute sodium hydroxide, and in the second step you have used concentrated sodium hydroxide. 3 aldol condensation steps. In 3 aldol condensation step, each alpha hydrogen is replaced by CH2OH group. And the final step is Cannizaro reaction, because you have used concentrated sodium hydroxide. So this compound is used to prevent heart disease or heart attack. And the last, okay, I have seen the structure of this compound in jeemains or in medical like this. See, in entrance, medical or engineering, I have seen the structure of this compound like this. Like swastik. This compound and this compound are same. The reactions was given and option. This structure is not given in option, rather this structure is given in option. This is the correct, this and this actually same. See how this and this become same. Just fulfill the tetravalency of carbon by putting hydrogen. So let's see, carbon at the middle, CH2OH, 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 CH2OH. So there are 4 CH2OH. So this and these are same. Remember it. I have seen the structure in entrance. Clear? And the last topic. Whenever I have started Cannizaro reaction, I have told you that there is one exceptional compound which also undergoes Cannizaro reaction, though it has alpha hydrogen atom. This compound is an exceptional case which has alpha hydrogen atoms, still it undergoes Cannizaro reaction. So you know that during Cannizaro reaction 2 molecules are used. So you get one primary alcoholic group, one salt of carboxylic acid group. Question is why this compound has alpha hydrogen atoms, still it undergoes Cannizaro reaction? Because you know that methyl group has electron donating nature. So due to electron donating nature of 2 methyl group, this carbon prefers the attachment of base. This is the only reason. So what is the reason? Due to the presence of two electron donating methyl group, the carbon prefers to attack with base, that is OH negative ion coming from sodium hydroxide or potassium hydroxide. That's the reason. Clear? So please subscribe my channel so that I can reach with more and more new videos and new ideas, new technique and tricks on chemistry. So thank you for being with me. Thank you once again.